If you have it, it comes back positive 99%. But what percent of the time it doesn't, okay? That's if you have it. If you have it. 그렇다. Okay? 99% of the time. If, okay, Eunhae doesn't have corona. No corona. Okay. It comes back positive. 2% of the time.
Is error?
Error. This is always the case. What is the probability that Eunhae has corona given that her test comes back positive? Alright. I recommend drawing a tree.
tree 여기.
Alright, so let's say that, well, we can say Eunhae has corona. There's a 50% chance she has corona. We can say, I guess, or I don't know. She came into contact with a 확진자. 미안해요. She came into contact with Junhee, and Junhee has corona. So there's a 50% chance she has corona. Something like that. Alright, so I don't know.
Where's the problem?
Okay, I'm joking. Alright, so how are we gonna do this? So there's two options, right? It's that, you know, she has corona. So here's like the branch where it's like corona, no corona. Okay? And let's just say that, well, in Korea, 1% of the population has corona. Okay? And 99% doesn't. Let's just say that, okay? Eunhae gets a test. Alright? And we have positive and negative. And positive and negative. This is the general population, okay? This is the general chance.
What is A?
This is just positive, so positive, I wrote plus. And then this is negative.
So what was the question?
What is the probability that Eunhae has corona given that her test comes back positive? Alright. I'm gonna
Is it not?
You are on the right track. So, but here, yeah, 1%. Okay. Just do the math. Use this. Why do you use that? So what's B? What's B?
positive.
Don't look at my answer.
Okay. No.
We look at only 3.
That's right.
Okay. We have 2 events, A and B. What's B?
Positive.
Yeah,
Oh.
B is that the test is positive. What is A?
Una has a
Yes,
corona.
corona.
Has corona. Sorry. Okay.
Number is very complicated to find.
Okay. So write them as decimals.
Mm,
Write it as decimals, and it actually is not too bad. Okay. All right. What's the probability that she has corona and her test comes back positive? Well, she has corona, right?
Yes.
And it comes back positive.
0.1 times 0.99.
And 0.1% of the population has corona. I mean 1%, so 0.01.
A little.
Okay. 안녕 보세요. Okay. I rewrite without percentage. Okay. 0.01. 0.99. 0.01. 0.99. 0.98. 0.02. Wait, no, sorry, my bad, it's this way. 0.02, 0.98. Alright. Okay, EA and B. What is A? She has corona. What is B? It comes back positive. Alright, well she has corona with probability 0.01. And then it comes back positive on this branch with 0.99. So? That's the top. What's the bottom? What's B?
0.99.
You have to plus 1 times.
So, it comes back positive. Where does it come back positive? Here
Yes.
and here. So?
You have to plus 0.99.
Alright, 0.01 times 0.99 plus. So now we've got a different branch. This is a different result, so we're adding. We multiply when it's on the same branch, the same result, the same end. And then we add because this is a different option.
0.99 times 0.02.
What's this? Alright, okay. You can group it just like this. Right? Because 0.01 plus 0.02 times. Magic. Magic! Okay?
Okay.
And that's weird, right? Because the test came back positive. They said that she had corona. But it only comes back, like, she only has corona with a 1/3 chance if the test is positive. In this case.
Oh, that's strange.
Yeah. Isn't that completely counted? That's why conditional probability is hard. So the test came back positive, but she only has corona with 1/3 of a chance. This isn't real, I made this up. But theoretically, if this were the case, and this were the rules of the corona test, this is how it would be. It would only be 1/3 chance that she has corona. Now, what's the probability that she has corona if it comes back negative? So now B equals negative. The probability she has corona if the test comes back negative. So.
A is she has corona.
What do you think? The probability that she has corona given that the test was negative. I solved it now.
It is complicated.
할 수 있어요. 할 수 있어요.
I need to calculate the number.
No.
I solved it.
Oh.
Yep. Wait, hold on. Yeah, I wrote the wrong thing by accident on this one. Yeah, he's right. That's really small though, right?
Small?
Right? Isn't it really small? Because if you think about it, this is like really small. This is like 1 out of 1, like, this is, and this is almost, this is like close to 1. So that means that if the test was negative, she basically, you know that she doesn't have corona. But if the test is positive, it's more likely that she doesn't have corona than she does. You're safe from corona.
Strange.
It's weird, right?
Why this has happened? Is it strange?
Because it's conditioned. It's the conditional. So if you think about it, what's the probability that she has corona?
1%.
1.01.
Okay. Where's all the cases where she has corona? Yeah. So it's gonna be that. Yeah. So it's really, if you think about it, it's a really small chance that she, like, that most of the population doesn't have corona. All right?
Yes.
So we're conditioning on the fact that she has corona, which is really kind of rare, right? Or no, we're saying that she has corona, but we're conditioning on something. So, okay, we're conditioning on what the test result is, but it's still small that she has corona. And because of that, even when the test comes back positive, it's still not likely. It's hard because it doesn't make sense. Like you think, why? But if you think about it, like, it's unlikely she has corona to begin with. So it's more likely that she doesn't have corona and the test came back positive than she does have corona and the test came back positive. Because corona is so rare in Korea. Not if you go to America. Okay? Can I erase?
Yes.
Okay, we'll do another similar problem.
So it means statistics is fake?
Statistics are very iffy because of this. Actually, there was so in the 2008, the US housing market crashed. And a lot of the reason for the crash was that the economists, they forgot about independence and dependence. So if you think about it, the housing market is dependent on a lot of other things, right? So if the overall, say something else crashes, say the tech market does bad, then people are going to lose their jobs. Then people aren't going to be able to afford houses. What happens to the housing market? No good. So the thing about economics, which I don't like about economics, is that everything is dependent on not only other things, but what other people do. What people do. It depends on what people do, individual people do. Now the thing is that a lot of economics theory is based on things being independent. And let me remind you, if A and B are independent, this is very different. Because this just equals, what does this equal? This top part equal if A and B are independent?
P possible A times possible B.
Yeah. And it's just, the thing is that this is just that if they're independent, because it doesn't depend on anything else happening. Okay. So let's do another conditioning on a different event. All right. So let's say, all right, Junhee gets a good score on her exam.
Wow.
With a 95% chance.
Oh.
Okay? If Junhee doesn't do well, then Eunhae is sad. Eunhae is sad. So if Junhee doesn't do well, then Eunhae gets a bad score with 90% if she doesn't do well. What is the probability that Eunhae gets a bad score? Otherwise, Eunhae always gets a good score. She always gets a good score if Junhee gets a good score. But if not, she's sad.
If Juni get a good score, Une is not likely to bad score.
If she always gets a good score if Junhee gets a good score. Because she's happy.
Yes.
Okay, let's draw the tree.
Okay.
I want to make it a little bit harder, so I'm gonna say, let's just change this. Okay, fine, you can draw it easier. Okay.
What's the question?
What's the probability that Eunhae gets a good score?
Get good score.
Yeah.
What a keyword?
Overall, what's the probability she gets a good score? So we know it's a 90% chance if Junhee gets a bad score, then she gets a good score. She gets a bad score 90% of the time.
If me or if I study not.
Yeah, you don't study, she also doesn't study because she's playing with you.
Okay.
You're together. So then she does bad. She does bad if you do bad usually.
If I will, Yune is well too.
Always.
Always well.
Always.
Always well. Alright. So in this case, what's A and what's B?
A is Une has a good score.
Yes. No, bad. Alright, good, yeah. Well, it's easier to say bad, but yeah, okay, we can say good. Alright, what's B? So we want to find P of A, right? Okay. So we just want the probability that she gets a good score. The easiest way to do this is to say, okay, the probability that she gets a good score given that Junhee gets a good score is 1, okay? So that's 1. And the probability that she gets a good score given that Junhee gets a bad score, well, it's not 1, it's given, so it's see, this is why I have to write it out. Probability that she gets a good score given, yeah. Which equals, so the probability that she gets a bad score, given that Junhee gets a good score, is this thing, and it's 90, so it's, alright, so we know what that is, we know what this is. What's P of B?
What is B?
What is B?
She get a good score.
Bad score. I mean good score, sorry. Alright. Yeah, so, yeah, this is, sorry. Alright. So the probability that she gets, let's do, why did I write it like this? Okay. let's do bad score, okay? So, if he gets a bad score, that's 0.05, right?
Yes.
This is this is, sorry, 0.05, this is 0.9, because it's a 90% chance. Okay? This is assuming the bad score. That's 0.05. Okay? What's the probability of a good score and a bad score? Like, so the probability that she does well and you don't?
B is Junyi study bad and A.
Yeah. B is you do bad. Okay?
Yes.
What is A? Alright. Alright, so what do we have? We have 0.9 times. Alright, we could also, so I'm going to do it that she gets a bad score, because then we don't have to worry about the other case. And then we can just take 1 minus. Okay, the probability that she gets a bad score is 1 minus the probability that she gets a good score.
Yes.
Right?
Yes.
Alright, so there's 2 options for good, and there's 1 for bad. So I'm just going to solve this and then subtract from 1.
Okay.
I can do that. Okay? So it's the same thing, because it's like, if I'm taking this is the probability that she does bad. Right? Because she never does bad. If you do well. So, right? So this is 0.05. Right?
Yes.
And then this equals 0.9. Why am I writing? Yeah. Okay? So what's this? Which is the probability that you do bad and she does bad?
0.05 times 0.9.
Yeah. And what's the probability that you do well and she does bad? She never does bad if you do well. It's 0. Okay. And so then we get 1 minus 0.9 times 0.05. Or you can just do the good way. But you have to calculate more if you do that. So if you do it, that the probability that she does good is 1 minus equals 1 minus p of bad. Okay? So that's what we did. We did p of good is 1 minus p of bad. Because she either does good or bad. There's no in between. Okay? But if we were to do it the way that she does well, it would be like, okay, you need the probability that she does well given you do well, which is,
0.95.
So the probability that she does well, yeah. Yes, is that right? Yeah, yep. Probability that she does well and you do well is 1 times 0.95 and the probability that she does well and you don't do well is and you add them. Okay? So she does well a lot of the time. You know? But it's not as much as you'd think. Because this is very, very small, right? Very, very small. So she basically does well the same as you do. Okay? Even though it's only 90%, it's 90% fail if you fail. Okay? Oh, it's hard. This is so, you need to just draw the thing. It's so confusing. Like, so many people, they just mess this up too. Alright. Do you guys know dice?
Dice? No.
Okay.
I will bring my home next time.
Oh, you bring them? Woo! Okay, we talk about dice at some point. Because we can do questions with dice also. And I can ask you about the sum. Like if we have 2, I can ask you the sum. Like, so you know they have 6 sides, a die.
Yes.
And what numbers, 1 through 6. I can say if we have 2 dice, what's the probability that the sum, if I add the 2 numbers, so I roll both of them, right? I add the number on dice 1 to the number on dice 2. And then I can ask you, what's the probability that the sum is 3? Or what's the probability that the sum is 7?
What is sum?
The plus. Okay, so I roll the dice. They have numbers 1 through 6, right?
Oh yes.
And I have 2 of them.